Hi everyone, this is VK. Welcome to Smid World. Here I am with another video. In this video, we will learn about the difference between the synthetic oil and conventional oil. What is synthetic oil? Synthetic oil is a lubricant made up of artificially made chemical compounds. These compounds are made by breaking down and then rebuilding petroleum molecules. Under a microscope, a drop of synthetic oil shows millions of molecules all nearly the same size and structure. Examples: esters and polyesters, alkylate benzenes, and phosphate esters. Synthetic oil can be fully synthetic or a synthetic blend and be derived from multiple base types. What is conventional oil? Conversely, a mineral or conventional oil is the base oil. Used in a conventional oil is 100% mineral oil, which is obtained through the refining of crude oil. Here, the crude oil is distilled and cleaned up to produce high quality base oil. This is done without substantial molecule changes being made to hydrocarbons at the base oil during the process. A drop of conventional oil under microscope shows millions of molecules all with different shapes, sizes, and structures. Here are the examples. You can see the picture how conventional oil molecules, the sizes of the molecules different, and how the synthetic oil molecules are in the same size. The synthetic oil produced through chemical process or not direct extraction from the like conventional crude oil. You can see the line diagram of the synthetic oil extraction. Conventional oil extraction primarily involves drilling into reservoirs with a natural pressure to allow the oil to flow the surface. Here the picture how the natural oil extraction from the earth. What are the advantages of synthetic oil over conventional oil? The synthetic oils are created through complex process, including being chemical developed from petrochemicals to have exact molecular qualities needed for specific application. These processes remove impurities from the crude oil and enable individual molecules to be tailored to the demands to modern engines. These customized molecules in synthetic oils provide higher levels of performance and protection than conventional oils. Advantages and disadvantages of synthetic oil. So, what are the advantages of switching to a synthetic as opposed to conventional? When looking at the pros and cons, the synthetic lubricants can offer meaningful advantages. The following are some of the most significant advantages like a synthetic generally have over conventional oils. When exposed to a certain condition, like conventional mineral oils are usually more prone to chemical degradation like oxidation compared to synthetics. These harmful conditions include conversion by products, fuel contamination, water contamination, metal particles, acids. The pro-oxidants can extreme heat, example from the combustion. Exposure to these conditions commonly occur in engines. Oil degradation can cause floods, warnings, or deposits. Corrosion, viscosity change, and impaired engine performance. Synthetics have a naturally higher viscosity. This means the viscosity changes less as the temperature changes during normal engine startup and operating conditions. Viscosity is an important property of lubricants that produce the film thickness or clearance between metal surfaces that slides or rotate against each other. Without this film thickness, excessive friction and wear would occur. At extremely low temperatures, it is more possible for mineral oils to become so thick, so that high viscosity, and that oil is unpumpable, or is unable to circulate effectively within the engine. The lack of oil circulation can cause lubricant starvation conditions and engine failure. The synthetic engines oil are generally less volatile than mineral oil. This means there is less loss of oil to the engine's exhaust stream, causing atmospheric pollution. It could also mean less need for the oil between oil changes. Possibly the biggest advantage and the reason synthetic oil is so popular is that it has a longer lifespan than conventional oil. The recommended change intervals for the synthetic oil is around every 5,000 to 7,000 miles or hours, which comes first, with some brands touching much longer intervals. The few disadvantages of synthetic oil to be aware of include probably the most glaring downside of synthetic oil is the cost. Price of synthetic oil is around two to four times the price of conventional. Synthetics may be more prone to additives, precipitation during cold storage conditions. This stratifies certain additives which can potentially lead to their complete separation from the oil. The multi-grade motor oil using synthetics may exhibit slightly less fuel economy at highway speeds compared to mineral oil. This is due to the fact that the mineral oils require more viscosity in extreme groups than synthetics. This additive contributes to reduce the viscosity friction by a mechanism known as the shear-induced temporary viscosity thinning. Advantages and disadvantages, like you can see here. Advantages: the resistance to oxidation and chemical, the more expensive. It stands the temperature extremes better at cold and hot conditions. The possibility to precipitation and separation happens. The flows better at cold temperatures. Slightly lower fuel economy at a highway speed, like in automobile. May produce less sludge and surface deposits, longer oil change intervals, and more robust film thickness at higher temperature and higher loads. How to choose gear oil? While choosing a gear oil for your equipment, you can make the right choice based on the following factors. The first factor one is the viscosity. Is one of the most important property of the gear units move against each other, and the viscosity of the oil ensures that it forms a thick layer between these moving units, preventing wear and tear. You can find the optimum rate of viscosity for your equipment in its usable manual. Like a gear loop can be divided broadly into three categories based on use, which is the R&O and stuff and compound. The right fit for your equipment will be based on its operating condition. The combination of additives can be used to form the support required for gear oil to deliver high performance and production under extreme pressure conditions. Third one is the base oil. Selection is also crucial when choosing a lubricant. Based on your equipment needs, operating conditions, and time, you can select a mineral or synthetic based lubricant. While minerals have higher pressure viscosity coefficients and synthetics have a greater resistance to thermal and oxidation. Higher viscosity grade of synthetic also enables performance delivered in extreme temperature conditions. Industrial gear oil features that contains extreme pressure properties to combat heavy loads, say thermally stable, resists oxidation and sludge formation, separates freely from the water, maintains film strength and viscosity, remains tacky, cleans and wears, contains no solids that can be removed during filtration. The classification of industrial gear oil types. The most extensively referenced industrial oil classification is the one established by ANSI and AGMA, American National Standard Institute, or American Gear Manufacturers Association, that classifies industrial gear oils. The gear oils are classified into four types as shown below, like R&O and EP and compound type, the synthetic gear oil. Here we can see the temperatures, gear oil type and formation, and operating temperatures limits. Gear oil types like R&O and EP type, compound type and synthetic type. The temperatures are here 93 degrees and 90 degrees to 160 degrees as well. AGMA gear oil classification for the semi-enclosed gear units can open Yes, for the industrial application. Gear oil type and formulation. Minerals. The Argo type. Mineral oil containing oxidation, bitter and rusting bitter as an additive. EP type means mineral oil containing acetic acid or speed-based extreme pressure reagent acids. The compound type synthetic mineral oil of high viscosity grade of EP oil diluted with volatile non-flammable solvent. In gear lubrication, the most important of performance property is viscosity. Depending on gear configuration, number of gear conditions, gear oil of appropriate viscosity is to be selected as per the viscosity classification of industrial gear oils. ACMA specifies for high viscosity grades to ACMA also adopted viscosity numbers specifying the kinematic viscosity from 37 degrees to 98 degrees as open gear application. Classification is used to general for viscosity classifications industrial gear oils. The following table shows the mapping between ISO viscosity classifications and here you can see the temperatures and the ISO viscosity grade